Hello, hello, and welcome. I'm just going to go through a brief recap. Well, I'd say brief. I'll get to that in a second. A recap of circles from the Edexcel AS Level Syllabus or specification. I've just I've just recorded this once actually, and unfortunately my microphone didn't work. So I got 50 minutes it was, so it's not very brief. Hopefully now I'll be able to speed up a little bit. So circles, I'm just going to talk through quickly. I can't hit on every single thing that you need to do, but there's a couple of things that I want to touch on quickly. Firstly, perpendicular bisectors of circles. If you've got a circle and you take a chord going across there and you take a perpendicular bisector, it will always go through the center of the circle. Really useful if you've got another chord and you bisect that. So if you don't know the center itself, but you've got two lines that you do know something about, then you might be able to find the center there. So that's really useful. It also, there's a lot of different stuff we can do there. So a lot of questions we'll ask about that. Second thing is general equation of a circle and how to factorize it into that form. That's another thing that I'm going to be looking closely at. So the first thing I just want to talk about is the general equation of a circle. Hopefully from GCSE or kind of prior kind of knowledge, IGCSE or something along those lines, you know about the general equation of a circle. So if you take a circle represented on the origin and you take a random point or a point up here, let's call it X, Y, we connect those. We know this line goes from the center to the circumference. That's R, the distance there is R. We also know that this point here is X, and likewise for this point up here being Y. So we know that the distance down here is y, and the distance along the bottom here is x. And we have created a nice right-angled triangle. That gives us, using Pythagoras' theorem, that x squared plus y squared is equal to r squared. So we hopefully already know that bit. So how do we off-center this and basically make it a bit more general? Let's just take it up into the first quadrant for now. So we'll take it up here and we'll center it just on, let's call it AB. And we take a point over here, same point, x, y, just a generic point, and see what's happened. So there's a few things that's different on here. We can still draw the line to get the radius. I'm just going to change where I put that AB. But we can still get the radius from this. And that's still going to measure R. But the difference here is that these two lengths that we had before are going to change size. So we actually want to know what is this length here and what is the height of my triangle. So keep in mind that this top bit here is going to be y because that's where the point is. And likewise down here, this is going to be x. This bit is A. And this bit over here is B, just because we knew the center. So how do we find the difference between these, or the distance between them, more importantly? Well, imagine this was 5 and this was 8. To get from here to here, we know it's 3. So it's this one, take away this one. And it's the same for these variables up here. So you're just going to do x minus a. That will tell you the actual distance there. So this distance here is x minus a. And same here, it's going to be y minus b. Hopefully you can see now the generic form for the circle using Pythagoras' theorem is going to be x minus a all squared plus y minus b all squared, and that's going to be equal to your radius squared. So that's the general form of a circle. Interestingly enough, if you were to multiply this out, you're going to get some x squared, you're going to get some x terms. So in this case, it'll be 2ax. You're going to get a constant a squared, and it's the same for the y's, plus b squared, and that's going to be equal to r squared. So we get some x squares, we get some y squares, we get some x's, some y's, and then a load of constants. This is sometimes how the question will be presented to you, and you're going to have to get it back into this format. Obviously, you're not going to have all these a's and b's, they're just going to be different numbers, but you're going to need to try and get it back into the format above, and that's another thing that I'll be focusing on during this. One other thing I'm just going to do just on the next page is just talk about a little bit if you've got 2 points. If you've got 2 points, let's say 1, 7, and let's go with 9, and what else could we have here? Let's say 16. Now let's go at 19. Make it slightly nice. You need to know how to find the midpoint. So if we've got a diameter and we know the two endpoints, we can find the center of the circle, for example, just by finding the two midpoints. Keep in mind, you've got some horizontal distance here, and you've got some vertical distance here to cover. We want to know what's right in the middle of these two things. So you know that this starts at 1 and it ends at 9. This starts at 7 and it ends at 19. And you just want to know what's the number in between. Hopefully you can see it's just the average here, but the distance from 1 to 9 is 8. Half in that tells us we need to travel a distance of 4 to get to the middle. So this must be 5. And you can see here that distance there is also 4. So we're right in the middle if it's 5. So the x coordinate here will be 5. And all you're doing here is taking the average of the two endpoints. So we're doing 1 plus 9 divided by 2. That's our x. And for the y's, we're going to do 7 plus 19 and divide that by 2, which is going to be 13 in this case. So our formula is just add together the x and divide by 2, add together the y's and divide by 2, and that'll tell you the midpoint. So these are all prerequisites you should already know. A few of the things that you'll need to know for sure: completing the square, solving quadratics, all of that kind of business. We'll get into that in just a second. So one quick question, well, it's not a quick question at all. One question, it's not a past exam question, but it is quite a thought-provoking question. So based on what we've just kind of said, we know straight away the center for this is going to be 5 minus 3, and the radius is going to be the square root of 10. Remember, it's not squared here, so we need to square root it over here. Let's have a quick look at what that might look like. So 5 minus 3 is somewhere right here. And the circle itself, it's got a radius of root 10, which is just over 3. If this is minus 3 down here, it's just going to peak above. So it's going to come up here, and it might look something like that, but a bit of a nicer circle. And then we want to have 2 lines, or at least a line with a gradient of minus 3. That is a tangent to this. So hopefully you've just read that question. And that's going to give us this line here. And there's going to be another line just over here. And the reason it's saying 2 possible equations is where it's minus 3, we've got 2 parallel lines. And that'll be all the way around this circle, actually. So every single point on this circle where it's got a tangent, it'll have another tangent with equal gradient at the opposite side. I'm going to call this L1 and this L2, and we'll get those in just a sec. So we know this is centered at 5 minus 3. How in the world could we find, I'm just going to delete my axes. I don't actually need those. How am I going to find what these 2 lines are? Well, in order to find 2 lines, we need a gradient, which we've got. But we also need to know a point that it passes through. So we need a gradient and we need a point that it goes through. The easiest point for us to find that it goes through are the ones that are actually on the tangent, because we've got the bit of information about the gradients, we've got the circle itself to try and help us. So that's where we're going to aim. To start this then, if we know these have a gradient of minus 3, then the line that connects these together, which passes through that center, must have a gradient of of 1/3. So remember that the gradient and a normal always multiply together. So the gradient of a tangent and a normal multiply to be the -1, or it's the negative of the reciprocal, depending on what you kind of learn it as. So here, this particular line is going to have a gradient of 1/3. So that's this line just going across. I'm going to try and find, hopefully, the equation of this line. Then I'll equate it with the circle, and that'll hopefully tell me these 2 points either side. I'm hoping I can fit all of that just down this right-hand side. So let's give that a try. So I'm going to find the equation of this. I know it's going to be of the form y minus y1 equals 1/3, so that's the gradient, x minus x1. Now this y1 and x1 needs replacing with a coordinate that it passes through. So in other words, the center. So this one's going to change to a +3, that's double negatives, and this one's going to be a -5. All I'm going to do is rearrange this, and I get y equals 1/3 x, and then this is going to be minus 14/3, and that's my nice equation for y, I suppose. From here, we're now going to substitute that into the equation of the circle. I'm going to put that into the equation of the circle. So I've got x minus 5 all squared plus y plus 3 all squared equals 10. So instead of this y, let's give myself a little bit more room here. I'm actually going to write this. So I've got 1/3 x minus 14 over 3 plus 3 squared. This bit here will simplify to be minus 5 over 3. And I know that because we had a positive 3 here that we added. Well, we actually subtracted it from here. So we're actually just working backwards. So that's going to be minus 5 over 3 just in there. I'm going to expand all of this. So x minus 5 all squared expands to be x squared minus 10x plus 25. Plus this one, a little bit trickier. I get 1/9 x squared. And then here I'm going to get 5/9 of x, but negative. But I'm going to get that twice, one from each bracket. So that's 10/9 of x plus 25 over 9 from this thing squared. And that's equal to 10. I'm going to rearrange it all and see then what happens. So my x squareds, I've got 9 here, 9 over 9, sorry, plus 1. So that gives me 10 over 9 x squared minus 10x. And then I've got this minus 10 over 9. So that's minus 90 minus 10. Gives me minus 100 over 9 x. 25 minus this 10 is 15. And then 15 plus 25 over 9 is going to be 160 over 9. That's equal to 0 now. So just rearranging gets me to here, which is, again, if we now divide everything by 10 and times through by 9, we get x squared minus 10x plus 16 is 0, which gives us x minus 2 and x minus 8 is 0. So again, just a nice factorize there. So times them together get 16 is minus 2 minus 8, and when you add these, you get that minus 10. That gives me that x is 2 or x is 8. Apologies for speeding up here. Given that I've already gone through this, I'm just running through a little bit faster than I did previously. So apologies if there's anything that I miss out that you're not too sure on. Let me know in the comments, or just let me know and I'll get back to you. So number 2, for y, when x is 2, we want to put that back in. I'd use the y equation. So I've got 2/3 minus 14/3. That's going to be minus 4. So minus 12 over 3. And then for the 8, I've got 8/3 minus 14/3, which is going to give me minus 2. So that gives me these 2 points. So this is going to be 2 minus 4. And over here is going to be 8 minus 2. So not the best picture so far, but it'll do for now. Oh, what can we do from there? Now, we just do the same thing. So all of that is to find those points. We now go back and do the same thing we did for the diameter of this circle for line L1 and L2. So for L1, we know y minus, now for L1, it goes through this one. So it's y actually plus 4 is equal to, and we're told in the question, the gradient's minus 3. And then it's x minus 2. And we just need to expand and simplify that. I get y equals minus 3x. Minus 3 times minus 2 is plus 6. Take away this 4 is a plus 2. So that's my first question. And then for L2, I do the same thing. So I've got y, and then instead of plus 4, it's going to be plus 2 is equal to minus 3. And it's x minus 8. So remember that this one had the coordinate 8 minus 2. So that explains where that 8 and 2 is. And this one had coordinates 2 minus 4. So from here, we get y equals minus 3x. Minus 3 times minus 8 is positive 24. And then take away 2 is a positive 22. And then my 2 lines there. Make sure you put them in the right format. My question asks for y equals mx plus c. That's the format they're in. Sometimes they might ask it for ax plus by equals 0 or plus something equals 0. Whatever format they ask for, just make sure you put in there. Okay, on to past exam questions now. So this one's the first one, very much like I was talking to at the start of this, where we're given a expanded form and we want to work backwards. So the key here is they always give it in a bit of a mixed up fashion. You want to get together your x's together. So here I've got an x squared, just down here, plus 4x, and then get your y's, so y squared minus 2y, and then just leave that other constant just kicking around at the end. What we're going to do is we're going to factorize, well, I say factorize, we're going to complete the square on both of these separately and then bring it all together. So when you complete the square on something, let's just start on here. So you take the x half of this one and then square it. What if we expanded that, what we get is x squared plus 4x, but then you get this 2 squared, which is plus 4. We only want x squared plus 4x, so we're going to have to remove this 4, so we take it away. Now, that always is this number here squared, so that's the kind of format for completing the square. From this, you want to now do it for the y's, so y minus 1, take away, and then in brackets, I'm going to put minus 1 squared. Now, minus 1 squared will be negative, so overall, this will be a minus 1. So we're going to have a minus 4 and a minus 1, and then a minus 11. So 4, 1, and 11 is 16. So I'm going to move that all over to this side. So I get x plus 2 all squared plus y minus 1 all squared is equal to 16. So from this, I can do part A and part B. So A, the center, that's going to be minus 2 and 1. So whatever makes each bracket 0. And then for part B, the radius, remember to square root if it's not already. So I've not written this as something squared, so I need to square root that. So it's going to be 4. Part C, whereabouts does it cross the y-axis? Well, the y-axis, that implies that x is 0. So when it crosses the y-axis, x needs to be 0. So the coordinates here, it's going to be 0 something, and I just have to work those out. So if I put x is 0 into, I'm actually going to use this equation here. So the one that we've just found. So x plus 2 squared plus y minus 1 squared. I'm going to put minus 16 equals 0. So when x equals 0, this then becomes 2 squared, which is 4, plus y minus 1 all squared, which is y squared minus 2y plus 1, and then take away 16 is 0. And I just want to try and solve this. Now, this, if you did it like this, it's actually a silly way to go about this. We've actually got a much nicer way here to deal with, or to help us. If I just strip this back, actually. So I've rushed into this a little bit. And what I should do is notice that when I put 0 into here, I get 4 from here, plus y minus 1 all squared is 16. I can actually just take this 4 across and start square rooting. So this gives me y minus 1 all squared is 12. Then I can take the square root. So y minus 1 is the positive or negative of square root of 12. Now, you might recognize that the question asks for simplified thirds. Root 12 is root 4 times root 3, which is 2 root 3. I'm going to simplify that up as well. So y equals 1 plus minus and then 2 root 3. So my coordinates themselves are going to be 0, 1 plus 2 root 3, or it's going to be 0, 1 minus 2 root 3. And they're going to be the two coordinates that I'm looking for. Any questions, just let me know, but hopefully that's a good start for us. So 8 marks in the bag there. I love these type of questions. I absolutely love completing the square. So it's a great kind of question for me. Next question comes from a much more recent paper, actually. This is from the new specification paper, and it's significantly harder than the previous one. There's a lot more thinking about it before you can get into this question. And I think this 3 marks is a little bit unfair. But I'm just going to start by drawing a couple of axes here. So let's have a quick read of this. So the first bit tells us that we've got a circle, and it lies only in the first quadrant, and it touches the x and the y-axis. That means that these are tangents. It's going to touch the x and the y just once and then come back on itself. And it might not seem it, but you've just been told so much information in just those 2 sentences. And the fact it touches these two means that this distance here is a radius. So this is r, and this distance here is a radius, which means this distance is r. That means our center is actually at the point r. And remember, the radius is also r. So we've got an equation here, x minus r all squared plus y minus r all squared, and that's equal to r squared. And then we've been told this equation here, 2x plus y equals 12, and we want to show what's going on down at the bottom here. So there's going to be a lot of algebra here, a lot of multiplying out and kind of bringing everything together. So I'm going to rearrange this to get y equals, and that's what I'm going to be substituting into my equation I've just found. So where I see a y, I'm going to put into here. In actual fact, I'm going to expand this first, because if I put this in as it is, I'm going to have 3 terms that I then need to expand. I'm not a massive fan of that. So this is x squared minus 2rx plus r squared plus, same for the y's, y squared minus 2ry plus r squared, and that's equal to r squared. So we can cancel out one of those r squareds and just let this equal 0 there. I'll just get rid of one of those because it'll cancel out. I'm going to stick y into here now. So I'm going to get x squared minus 2rx plus r squared plus y, which is 12 minus 2x squared. So that's y squared minus 2r times 12 minus 2x. I just need to basically expand that and simplify up. So I'm not going to be lazy, quite as lazy as I normally would be. I'm going to expand this properly. So I get 144 minus 48x plus 4x squared. Minus 2r times 12 is going to be minus 24r, and then minus times minus is plus 4rx, and that's equal to 0. Big thing to do here is to gather together all your x squareds, all your x's, and all your constants separately, because all they're doing here is gathering all those together. So we've got our x's, x squared, sorry, our x's, and the constants. So that's what I'm going to focus on here. So x squared plus 4x squared is 5x squared. That's looking like a great start. The x's, I've got 4rx minus 2rx, which is actually going to be 2rx. And my other x term is this minus 48x plus r squared minus 24r, and then plus 144. That's equal to 0. So I've done is take out all of the x's together, all the x squares together, and then the constants themselves. And this here is actually already sorted out. That's given to us just at the end. So the only thing here that we'll have to do is to factorize out an x from this middle term. Just like that. And that's it. We've got our kind of show that, or whatever you want to call it. So that's the show that finished. That's going to be 3 points. I think like that's a lot of work for 3 marks. A lot of work. From here, we're now told that L is a tangent to C. So it's a tangent. Find the 2 possible values of R, giving your answers fully simplified surds. There's a reason they've asked us to kind of break it up like this, and that's because of the discriminant. A tangent implies it's got 1 root, which further implies that b squared minus 4ac is equal to 0. We're going to make use of that now to try and find these values of r. So remember, in my actual equation here, I've got a is equal to 5, b is equal to 2r minus 48, and finally c is equal to r squared minus 24r plus 144. A little bit of a nasty one at the end there. So I need to put all that into here. So I've got 2r minus 48 all squared minus 4 times 5 times this horrible mess. And we want to try and set that equal to 0 and open it out and solve. It's doesn't look very nice. So 2r all squared is 4r squared. 48 times 2 is 96. Double that up is 192 r. And then 48 squared. This is where it comes in. I worked this out before. So 40 times 40 is 1600. 8 times 4 is 320, so double that up is 640, and then add on 64. So that's what's that? 2304. I did all that in my head in the last one, and now I've got no proof of it. Great. Anyway, minus 4 times 5 is 20, times by all of this. So I've got 20r squared, minus 20 times this is 480r, and then 20 times this is 2880. Personally speaking, or for my opinion, what I'm looking at here is my r squareds. I'm going to get a negative overall. I don't really like the idea of getting a negative, so I'm going to multiply everything by -1, or effectively take everything to the other side. So this becomes minus, a plus, this becomes minus, a plus, this is then a plus, and this is a minus. Oh wait, hang fire. Minus 20 times minus is actually a positive, so this is actually a negative, sorry. And this one is a minus 20 times a minus, times a positive, which would be negative, so that will become positive. Quick correction on my part, sorry. So sorting all this out, we get 20 minus 4 is 16r squared. 192 minus 48 is something. I think it's nice, not divide. 144. Really? Have I done something wrong here? Yep, I have rewritten it incorrectly, haven't I? 24 times 20 is not 448, it's 480. I did say that. So 192 minus 480 is much better. Gives me minus 288. Oh, sorry about this. It's slightly later than I expected. 2880 minus 2304 is going to be 576. And all of these numbers are actually divisible by 16. So divide this by 16, you get r squared. This one, you get something, let's say 18. And this one is something like 36. You're not going to be able to factorize this because they're giving us a hint here to say fully simplified surds. So you should probably use your calculator or do what I'm doing, which is to complete the square. So r minus 9 all squared minus 81 plus 36 is equal to 0. Minus 81 plus 36 is 45. So I get r minus 9 all squared is equal to 45. So when I take this across, and then square rooting, I get r minus 9 equals plus minus. Now the square root of 45 is actually 3 root 5. I'm just going to skip straight to that. So r is equal to 9 plus minus 3 root 5. And that's going to be my two answers there in simplified surd form. Hope that helps. If it does, rewind, try it yourself, try it from the beginning, and see if you can get all the way down to that, what I've just done there. It'll be a great practice for you to actually have a try yourself. Very good algebra question, a lot of kind of small algebra touches there with that negative and negatives. Just be careful of all of those. Luckily, I caught myself earlier on. Otherwise, I'd be running, kind of chasing my tail running in circles when I got further down here. So just be super careful about those. Okay, the next one I believe is my last one. It's not the easiest of questions by a long way, so it's going to take a little bit, but technically I should be able to do it in about 10 minutes. So a circle C with center at minus 2, 6 passes through the point 10, 11. So the first thing I'm going to do is try and draw this. We're asked to show that the circle C also passes through the points 10, 1. So let's imagine here's 10, 1 and here's 10, 11. The center is minus 2, 6. So if 1's there and 11's there, let's go with 6 being somewhere around here. Yeah, it should be right in the middle, shouldn't it? Shoop. And we want that circle to kind of continue all the way around and back up and through. So where these 2 points is 10, 11. And over here we've got 10, 1. That'll do. It's not the greatest of sketches, but it'll do for now. From this, we need to show that 10(1) is on this circle. So how do we actually do that? I think by looking at this, what we really need to do, apologies for the noise in the background, my cat is climbing on everything. I won't be a second. Sorry about that. Okay, so continuing where I got to. I've lost my track of thought now. Center point. Oh, find the equation of the circle. So we know that this equation of this circle is something along the lines of x plus 2 squared plus y minus 6 squared equals whatever the radius is. So if I can find that radius, then I'm basically onto a winner. And we can do that because we know this is minus 2, 6 in the middle. And we know that if we connect it up to this point here, we've got a radius. So we're going to find that distance and basically go from there. So it's just simple Pythagoras, find that distance itself. The distance from minus 2 to 10 is 12, and from 6 to 11 is 5. And this is a very nice 5, 12, 13 Pythagorean triplet. So I know that the radius there is 13. And of course, for it to be completing my equation, it needs to be squared there. So that's the equation of the line. To show 10(1) is on there, I need to put it into here. So I'm going to consider the left-hand side. And I'm also going to do it with the point 10(1). So putting 10 into here, I get 10 plus 2 squared plus 1 minus 6 all squared. That's equal to 12 squared plus minus 5 squared. Now, this is the same as 12 and 5, which is what we dealt with a minute ago. So just here, 12 and 5. So therefore, that is actually 13 squared. So you just want to go through. If you work this out, it's 169, which we know is 13 squared. So we've got the tangent. We've shown that that point's on the line. On to part B. The tangent to the circle at the point 10, 11. Oh, I can't quite draw this. Let's just imagine it's going to touch it up there and come down. And the tangent at this point just down here. So this one's P right at the top, and this is Q down here. We want to find the distance from P to Q. We want to show it's 58, and it says to explain everything carefully. Now, when I did this about 40 minutes ago, I wanted to do this by sight reading. I've never seen this question before, so I thought it would be a nice way for me to talk through it. I'm going to try and explain my thought pattern again at this point, because it took me quite a few minutes to try and ponder what I was going to do here. At first, what I was thinking is there any way of me finding P and Q? And I went through thinking about distances. I started thinking about cosine rules. I went down a bit of a dark track. But then I thought, what if we could just find the two different lines, the two different tangents? If this one here was L1 and this one was L2, if I knew the equation, the whole y equals mx plus c, then whatever this constant was would be what Q is. And if I did that for both, I could then just find the difference or the distance between them. And that's ultimately what we're going to end up doing here. In order to do that, however, we're going to need to find the gradients of these lines. So we're going to need to find the gradient of firstly this radius here and the gradient of this radius coming down here. That'll help us to find the gradient of L1 and L2. So I'm going to start with L1. So the gradient of L1. So this is going to be, first I'm going to find the radius. So I'm going to do 11 minus 6 divided by 10 minus 2, which is 10 plus 2. That's going to be 5 over 12. So that implies that my gradient of L1 is the negative of that reciprocal. So in this case, that's going to be minus 12 over 5. And it was at this point that I started panicking in the previous one, thinking, whoa, that can't be right. It looks nasty, but I'm going to persevere. And I did, and it's good because it is actually on the right lines. So on the next one, for L2, it's now 10 and 1. So 1 minus 2. Let's just do Oh, I said 1 minus minus 2 there. I meant 1 minus 6 divided by, and it's 10 minus minus 2. So this gives me minus 5 over 12, which implies the gradient for L2 is equal to positive 12 over 5. And so these are the two gradients we're going to use. And we're just going to use the y minus y1 equals mx minus x1 just to work out the actual equations of these lines. So remember, this one goes through the point 10, 11. And this one goes through the point 10, 1. It's very important that you've got a gradient and a point to do this. So y minus 11 is equal to minus 12 over 5 times x minus 10. And I just need to work that out. So I've got y equals minus 12 over 5x. Minus 12 times 10 minus 10 is 120. Divided by 5 is 24. And then 24 plus this 11 is positive 35. It's that number there that's super important for me because that tells me where the intercept is. That implies that p is 35. Stick that in a box, quite important. For the second one, I've got y minus 1 is equal to 12 over 5 x minus 10. From here, same again, we're just wanting to rearrange this. So y equals 12 over 5x, and this time it's going to be minus 24 because it's a minus and a positive, and then I want to add 1. So minus 24 plus 1 gives me a minus 23, and this number again is the bit that's important for me. So just stick that in a circle. That implies that q is equal to negative 23. Now, to get from minus 23 all the way up to 35, you can either do the difference between these. You can think about a little bit of logic, but that means that PQ is therefore equal to 35 minus minus 23. So the difference, which is 58. And at that point, you know you've done it right because you got the same answer or the right answer. And that's hopefully recorded properly this time. So thanks very much for getting this far. I think that is my last question. Yep. So thank you for watching. If you've got any more questions that you'd like to see or a different topic you'd like me to cover, please just get in touch. I have got some ideas coming up. So the ones that I've got on my list of things to do is firstly a recap of differentiation. It's a much bigger topic, so my main focus there will be optimization. Trigonometry, so how to use the identities that we've had a look at this time. And finally, vectors as well. So they're the three things that I've got coming up. If you've got any other questions, though, from this topic that you want to see me do, stick in the comments and I'll do a video on them probably, or just ask me at some point and I'll go through them. Thank you very much for watching. Hopefully, it's been some use for you.